I'm going to show you how to use MSFVenom. And MSFVenom is a payload creation tool, and it's a combination of MSF Payload and MSF Encoder. So look at the help files. You can see that there are many options for MSFVenom. I'm going to choose the -P option for payload. And we want this to be a Windows interpreter reverse TCP session payload. Pretty standard backdoor. And I'll make the format executable, and the architecture will be an x86 based architecture, and the encoder will be Shikata Ganai, which is a polymorphic encoder. And I'll also set the options. The option for the local host will be the IP address of the Metasploit server. This is what we want the reverse TCP shell to connect back to. So I'll look up via an ifconfig, it's .1.35. I'll add that IP address information as the lhost option to create this payload. And now I'll set a listening port. Any unused port is fine. I'll just choose 55s. And I want to go through 4 iterations. And this will be for the Windows platform. And then the -B is for bytes. And these are basically bytes that you want to avoid when this gets compiled. Some of these bytes may be well known from an antivirus perspective. So we'll enter that, and then we'll output that to an executable, which will be the initial iteration of our payload. So let's go ahead and run that. Alright, so you can see that it went through actually 4 iterations of the Shikata Ganai polymorphic encoding. And our next step is going to take this payload, and we're going to use this payload, which has been encoded, as input into Hyperion. And Hyperion is a tool that we'll use to encrypt the payload. So I've copied the payload into the Hyperion folder. Now that the payload is in the folder, I can run Hyperion to encrypt the MSFVenom payload. Now, Hyperion is a Windows executable, so I'll need to use the Wine Windows emulator to run Hyperion. So I'll get a fresh screen here, and I'm going to run wine hyperion.exe, and I'll use our MSFVenom payload as the input to Hyperion in order to perform the encryption operation of the payload. And then I'll enter in a name of the new encrypted payload, MSFVenom with hyperion.exe. You can name it whatever you'd like. And the next step in the process is going to be to obfuscate the executable at the machine code /opcode level. And I'll utilize a tool called PE Scrambler to do this. So I'm going to take this payload, which is now a product of MSFVenom. We created it initially with the Shikata Ganai encoder. We took that and then we encrypted it using Hyperion, and now I'm going to take that version of the executable and scramble the binary utilizing PE Scrambler. So it is a Windows executable, so we need to run wine, and we'll take this second generation executable, which is the MSFVenom with Hyperion, and that will be our input into PE Scrambler. -I for input, MSFVenom with hyperion.exe, and then the output will be the final version of our payload. And I'll give it a nice simple name, MSFVenom with Hyperion and PE Scrambler.exe. At least it's self-descriptive. You can see here that it armors the code, it generates some cross-references, and it does some other work to obfuscate the executable. So now that we have a working executable that has been encoded with a backdoor, the reverse TCP shell, utilizing a polymorphic encoder, it's also been encrypted, and then the binary itself has been obfuscated at the opcode level. Now that we have that, I'm going to take that and transfer it over to a Windows 7 machine. So this is our Windows 7 machine. You can see that I've essentially copied it over to this virtual machine. And I'm going to run Windows Defender Microsoft Security Essentials scan. And we'll see if it picks this up as malware. And it has not picked it up as malware, so we've evaded this scan. And before I run the Trojan that we just created, I'm going to start the Metasploit Framework Console server, because we need the Metasploit server to be listening for that reverse shell. So I'm going to use a multi-handler and set up a reverse TCP listener on our Metasploit server. And the payload will be in alignment with the payload that was set up at the client, which is the Windows Meterpreter reverse TCP shell. And we'll set up the variables such as the port and the host to be the same as we set it up in the payload. So the host, which is the server, is .35, and then the port, if you remember, we set to 55s. I'm also going to set exit on session to false, and this just makes sure that the session will remain intact and we won't get bounced out of the session once it's established. And now I'll go ahead and run the exploit now that all of the options have been set. So it's running as a background job. It's listening. So now we're going to see if double-clicking on this triggers any kind of antivirus activity. It doesn't appear to. You notice that took a little bit because it had to brute force itself, because Hyperion encrypted itself, or this executable, with weak 128-bit AES encryption and brute forced itself. And that's to evade antivirus. You can see that it's indeed established a connection back to the Metasploit server. We've evaded the antivirus on the Windows 7 machine, and this is our active session. Now I should have complete command and control of this machine, and all I need to do is interact with the session. And in this case it's session 1, so session-I. And you can see that we have the Windows desktop shell. So we have successfully created an executable payload, a Trojan, that uses polymorphic encoding, that's been encrypted, and that's been obfuscated at the opcode level. And we've evaded antivirus and successfully distributed and created a backdoor session into this Windows 7 PC.